Hello everyone. Hope you are doing awesome learning each and every day. So you're watching Code with Shubhajit, and today we will be discussing one of the medium level problems from lead code, which is minimum number of swaps to make a string balanced. Okay. So let's go through the problem statement and see what they're trying to say. We are given a zero indexed string of even length n. Okay. The string consists of exactly n by 2 opening brackets and n by 2 closing brackets. Okay. Till now we are able to understand that, okay, either opening square brackets and closing square brackets, and also the number of square brackets, that is the opening square brackets, is equal to the number of closing square brackets, so they are balanced. Okay, they are balanced in the sense they are an equal number. Okay, so we need to see that how many swaps are required to make them balance. So that's the task. So a string is balanced if it is empty. If it is empty, it's balanced. Fine. It can be written as AB. Both A and B are balanced strings. If I give you an example, it is in this form. Let's say, okay, so let's say this part is A and this part is B. They both are balanced. So AB is a balanced string, and that's how this whole string is balanced now. Okay. And if I go with the other case, that is this case, okay, where C is a balanced string and they are enclosed in a bracket. So they are talking about something like this. So this is C and they are enclosed in a bracket. Okay. If I take this example, can you see? Here, this part is balanced. I don't need to touch that part because that is already balanced. So why to waste time on that? Can you see the first element and the last element? They are opposite. If I swap them, that is only one swap, this whole string will be balanced and it becomes this. If you take this string, can you just see that if we swap the first and the fifth element, and if we swap the second and the sixth element, which are indexed as 0 and 0, 4 and 1, 5. If they do that, then this is the resulting string. So minimum number of swaps required is 2. Now let's go to OneNote and understand how this will happen. So I have taken a bigger example. Now these string balancing problems where we have opening and closing parentheses, brackets or curly braces, whatever, this is a very common problem, and I have also created a video of valid parentheses, okay, which is just to check that the string which is there is valid or not. So either here or here, on one of the sites, that video will come up, and I will also put that video in the description. You can have a look, and that is the basics. Okay, that is the basis of this video. If you watch that, then it will be really better for you to understand it here. Okay, so the intuition of the problem is that we need to find the minimum number of swaps to balance the array. Okay, so first of all, I should think that whatever balanced part is there, if I just remove that, and the unbalanced part will be remaining with me, and I just have to balance that. So precisely what I'm saying, that if you see this part, index 1 to 2, this is balanced. Index 4 to 7, this part is also balanced in itself. So if I remove them, then whatever string we are remaining with is this. So this is the string which we have to balance. And for balancing this, how many swaps we need? We just need, if you're able to see, one swap. If we swap these two, what output we are getting? We are getting this. This is as it is. This is as it is. And this will come at the last now. So now they are in the form of A and B. Both are balanced. So for balancing this whole bigger string, we actually just need a single swap, which is the first and the last element. If we swap, the whole string will be balanced. And how do I come up with that? I will first remove these parts of the string which are balanced, and then whatever remaining characters or remaining brackets which we have, I will try to balance them with minimum number of swaps, and that's my answer. Now what data structure we will be using? If you have seen the video which I have shared, like which I have recommended you, then you would have understood that for such type of scenarios where we need to check the balancing part going back, we will be needing a stack data structure. Okay, let me take the stack. So the stack is a last in first out or a first in last out. So whatever element goes into the stack, it goes as one over the other, and whatever the last element we have put, that is the first one to come out. You can just think of it as a tunnel which is closed from one end and open from the other end, and only a single person can go inside one by one. That much space is there. And when the people have to come out, how will they come? How will the order be? The first person who has gone in will be the last one to come out. That's the stack. Okay, so enough of explanation. Now let's get to the actual traversal of the logic. Okay, so we will be having a pointer. So initially the pointer will be at index 0. Okay, and it will move till the end, as we need to remove the parts which are balanced, right? So whenever we have an opening bracket coming in, okay, we will just push it to the stack. That is the first rule. Okay, so if we have a closing bracket coming in, then what we will do, then there are some of the checks which we need to have. So whenever there is a closing bracket, we will check whether the stack is empty or not. If the stack is empty, then we will push the closing bracket to the stack. We can't do anything with that, right? If the stack has some element on the top of it, then we will check that whether that element is an opening bracket. If that element is an opening bracket, then we will just pop that element, because we have found one matching closing parenthesis to that. And now that opening bracket on the top and the closing one just coming after that, they are balanced now. So we will ignore that. So that's why we pop the top element from the stack. Now I will start the logic. So I am at index 0, closing bracket. The stack is empty. I will put that closing bracket. Okay, good. Okay, I have an opening bracket. No questions. I will just put it like that. Okay, closing bracket. Okay, I forgot to do this. Yeah, so now we are here at index 2. We are at a closing bracket. I will check. At the top, I have an opening bracket. That's good. That's good. What I can do, I can just pop that out, because now if you see, there is a balanced part which has occurred. Okay, so I don't need to consider that. I will just ignore that part. Coming to index 3, we have a closing bracket. Okay, we have a closing bracket. Now we will see whether the stack is empty. No, stack is not empty. Okay, so whether the top element of the stack, it's not an opening bracket, so I'm not finding a match here. So when I'm not finding a match, I will just push it to the stack. Okay, fine. Now coming to index 4, I have an opening bracket. Okay, no questions asked, opening bracket pushed here. Now I have index 5, which is an opening bracket. No question asked, push it here. Now I have a closing bracket. Okay, I have an opening bracket at the top. It's a match. So this part, yeah, this part is a match now. So when this part is a match, I will just remove the top. Okay. Now I will move it to the 7th index, which is again a closing bracket. Okay. So now I will check at the top of the stack that is it an opening bracket? Yes. So what I will do, I will just remove that first. It's removed. And I will move the pointer to the next. Okay, and you might be able to understand that this 4 and 7, that match has occurred, and now you can see that this whole thing is gone and this whole thing is gone previously only. So we are just remaining with these two in here. I think you are now able to visualize how the logic is going on. Now we are at index 8. We have an opening bracket. No questions asked. I will push it. I have an opening bracket. Index 9. No questions asked. I will push it. That's done. So the whole logic is completed now. And we have some elements in the stack. Okay. And you can see that whatever elements we have is of a certain order. Okay. If I pull these elements out, you can see that starting from here till here, if I go, starting from here, 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 if I go, initially two are closing brackets, then two are opening brackets. Now I challenge you, take any example, okay, of such type of closing and opening brackets having equal number of opening and closing brackets. The elements which will be left in the stack will always be in this order. There will be some elements which are of closing type, consecutively they will occur, and same number of elements. So here we have 5 elements which are of closing bracket, same number of 5 opening brackets will be there after that. Now you should understand why this is happening. This is happening because this element hasn't got anyone before that which is an opening bracket. this element hasn't got anyone before this which has an opening bracket, and that's why they are pushed to the stack as it is. Now this pattern is something which will help us in calculating how many swaps are required. So from this stack what we get is we have 4 elements, 2 of them are closing, 2 of them are opening brackets. Okay, so here I just want you to understand that the number of opening square brackets or closing square brackets is even. We have 2 closing or 2 opening square brackets. Okay, so in that case I have to make just one swap. Let's make it a bit more in number. If we have 3 closing and 3 opening square brackets, in that case what we will do, in this case we have the number of opening or closing square brackets as 3. Can you see? It's 3, right? So in that case I have to make this as the first swap and this as the second swap. So I have to do 2 swaps. Now let's go a little bit more. When we have 4 closing, 4 closing, yeah, and 4 opening. In that case, I have to make this as the first swap and this as the second swap. So what will be the final array? And it is balanced. Can you see a pattern here? If we go on and on, you can extrapolate that pattern. But here, when we have 2 opening or 2 closing brackets, in that case, the number of swaps required is 1. If we have odd number, then the number of swaps required is this. If we have even number, the number of swaps required is, can you understand the pattern? If it is 2, it's 2 by 2, 1. If it's 3, it's 3 by 2, which is in Java 1, but as it is odd, I will add one more to that. As it is even, 4, 4 by 2, and if it would be 5, then 5 by 2, it is 2, but as it is odd, it will be 3 number of swaps required to balance the array. And that is the whole logic. So whatever the size of our stack will be, so in this case our size of stack is 2. So what is the number of closing or opening brackets? That is the size of the stack. So stack size by 2, that is our, let's say this as n, which is number of opening or closing. In that case we have to check if n is odd, in that case it will be n by 2 plus 1. If n is even, in that case it will just be n by 2, and that's the logic. This is a basic maths part, but this is the main logic. This one is the main logic, okay, which you have to understand how we are filling it in stack and how we are actually ignoring the part which is already balanced with the help of this stack. Okay, so now let's go to the second part of the video, which is the coding part, and I will see you there. Okay, so for saving time, I have initialized some of the parts and written a bit of code structure, but this for loop where the actual logic resides, I will write along with you guys. Okay, uh, so we have taken a stack as st, okay, and I am storing the length of the string inside the variable sz. I will be running a for loop over the whole string. I is equals to 0, I is less than sz I plus plus, the standard for loop, and I will be populating the stack, popping it, pushing to it, and then whatever stack comes out after the for loop is the one which is unbalanced, totally unbalanced, and we have removed all the parts of all the balanced parts from there. Okay, so as I have told you the logic, the n, this n is the number of closing brackets or the number of opening brackets, any one of them basically, which is stack dot size by 2, and the swap count will be based on n. If n is even, then n by 2 plus n modulo 2. So it will work for both of them. What is n modulo 2? If n is even, it is 0. What is n modulo 2 if n is odd? It's 1. So whenever n is even, it is just n by 2. And whenever n is odd, it is n by 2 plus 1, as I have explained you. Okay, and I will return that. Now let's go to the actual logic. So in this, we will check that whenever I have something as an opening bracket, I will not ask any question. Or else, if my stack is also empty, then I will not ask any question and I will just push the character which is at ith index to the stack. It will be better if I actually put this character inside a ch. So if ch is double is equals to the opening, or either the stack is empty, in both the cases I will push that character to the stack. And after pushing to the stack, we just need to continue the loop. Okay, so the loop will again start from next I pointer. Okay, so after this is done, I will check if, sorry, else if it means that our condition of opening bracket or the stack empty is gone. It means now the stack is not empty and the character is a closed character. In that case, I will check that if st.peak, if its double is equals to an opening bracket, opening square bracket. What I have done, I know that the stack is not empty because it has surpassed this condition, right? The stack empty, if it was true, then it has gone inside this and it will start the loop from there again. But as stack is not empty, I am coming here and I can check the top element of the stack, and if it's an opening bracket, and I know if it's coming in the else if condition, as I have told earlier, that it's definitely a closing bracket now, because this condition is not true. It means it's definitely a closing bracket. Stack is not empty. It means I have checked that the top element of the stack is an open bracket. Boom. It means that I have found a match. I have found a balanced set of an opening and a closing bracket. In that case, what I will do, I will just pop the top element of the stack to make the balanced things out of the stack. Okay, that's done. But even if that's not the case, it means that the st.peak is not this opening bracket, it's a closing bracket. In that case, very sad, I will just push the element to the stack. And whenever this whole logic will end, our stack will be having only those elements which are not balanced. Okay, so when we get that, we can just find the size by 2, and I have explained this before also. Let's try to run this. Okay, yeah, it passed for all the 3 test cases, and that's great. I will tell you about the space and time complexity here. So if you see that here we have uh, a single loop going over the whole string, right? So the time complexity here will be big O of n. Okay, and as we are using this whole stack here, okay, so it is actually getting the elements from this array only, so the maximum size which it can have is n only. So that's why the space complexity is also n in such case, as we are using an extra stack of size n. I hope you are able to understand this. I will highly recommend you to take more random examples and check the logic with that, do dry run and submit the solution and see if all the test cases are passing or not. Please do comment on the video if you are not able to understand any of the part. We will be really happy to help in that. And that's all for today's video, guys. Hope you have learned a lot. Thank you.